Question 11. The complex number w has modulus 3, argument 2 pi upon 3. Find the modulus and argument of minus I upon w conjugate, where w conjugate is the complex conjugate of w. Okay, so what is the modulus of minus I upon w conjugate? Well, this is just the modulus of minus I over the modulus of w conjugate. So this is just 1 over, and then the modulus of w conjugate is just the modulus of w, so this is just going to be 1 over 3. What about the argument of minus I over w conjugate? Well, this is going to be the argument of minus I minus the argument of w conjugate. But the argument of w conjugate is the negative argument of w, so this is just the argument of minus I plus the argument of w. So that's just going to be argument of minus I is minus pi upon 2. Argument of w is 2 pi upon 3. And that gives me my final answer, which is pi upon 6. Hence, express minus I over w in the form a plus ib, where a and b are real, giving the exact values of a and b in non-trigonometric form. Okay, so minus I over w, well, we're told to not do it in non-trigonometric form, so we're told to not do it in trigonometric form. So the first thing I'm going to do is I'm going to do it in trigonometric form, and then I'm going to change it back. So the modulus was a third, and then I go cosine pi upon 6 plus I sine pi upon 6, right? So what do I do with this? I can evaluate. So if we recall, pi upon 6 is one of the angles in our famous triangle, the 1, 2 root 3 triangle, where this is pi upon 6, and I hope, yes, there we go, it's all back now. Okay, and this angle up here would be pi upon 3 and 90 degrees. So, if this is our triangle, and I've got sine of pi upon 6, oh, you may ask, how did I know this is the 1 and this is the root 3? This is the short edge, so it should have the smaller angle. This is the bigger angle, so it should give me a bigger edge, right? So that's how I get it. And so that means cosine pi upon 6. Cosine is adjacent over hypotenuse. This is root 3 over 2. Plus I, and then I'd have 1 over 3, and sine pi upon 6 would be 1 over 2. So this gives me root 3 upon 6 plus I 1 upon 6. So the last part of this question, find the possible values of n such that minus I over w conjugate to the power of n is purely imaginary. So we saw something similar in the previous part. You can think a purely imaginary number, real axis, imaginary axis, where would it lie? Well, it has to lie along the imaginary axis, right? And so this means it has an argument of either pi upon 2 or minus pi upon 2. And in fact, it has these recurring at intervals of 2 pi. And it turns out then that if this is purely imaginary, then it has argument of a purely imaginary number. Let's call it I times y, right? Will equal to either, or will always equal to pi upon 2 plus some constant multiple times pi, where k is an integer. And why is that? We can think of it, this is pi upon 2, and to get to here, I would just add pi, or I start, and then to get back, I could add another pi, and then another pi, and then another pi. So you can see, adding pi each time takes me from a purely imaginary number to a purely imaginary number. This number at the front, I could have chosen minus pi upon 2 as well. The logic is completely the same. So this is the pattern that I'm looking for. So how do I find that? Well, first thing I'm going to do then is I'm going to ask, what is the argument of minus I over w conjugate to the power of n? And that's of course going to be n times the argument of minus I over w conjugate, which is what? We just did this, right? Pi upon 6. This is n times pi upon 6. And I want this to equal to pi upon 2 plus k pi. So I have 1 over 6 n times pi is equal to 2k plus 1 pi over 2. And so again, we can simplify this so that the pi's, they can cancel off. 6 comes over here, and we get n is equal to 6k plus 3, or in other words, 2k plus 1, where k is an integer. Yep. So this is our final answer. The possible values of n are the values where n is equal to 3 times 2k plus 1 for some integer.